here, welcoming you all to the finale, that is day 5 of the program. Ladies and gentlemen, we will have 3 sessions today, and we will have the online exam from 3:45 p.m. onwards. So today we will have our first session with our very own Mr. Avi, followed by 2 sessions by Mr. Roshan Rawat. I hope Avi sir is recovering and energetic, because we really look forward to Avi sir for the energy, for the enthusiasm, and for the dynamism he exudes in all his sessions. So may I now invite Mr. Avi to begin with his presentation on flood flow, ray marching, spear marching, cross processing stack. Over to you, sir.
Thank you, Soumya. Thanks for this awesome introduction. And yeah, we are good to go today. And I'm really excited that everybody is learning something from these sessions. And yeah, let's see what we have today. So, how's everyone doing? And would love to make it interactive. So please feel free to have conversation. And yeah, I feel sometimes a little lonely. So please make sure you are interacting. So I have a question that from yesterday's session, is there anything which is not very clear? Yesterday we built a ray tracer, and ray tracer is one type of renderer. Okay, so there are two major types of renderer. There are some others as well, like sign distance field and vector projections. Okay, so if I talk about ray tracer is the most accurate way of rendering, but most expensive way of rendering. Why it's very expensive? As yesterday I told you, it takes 2 million plus iterations if you have for example, if you have a single HD image which is 1920 by 1080p. Okay, so it takes 2 million rays to fire from that one position, and that those 2 million rays do every bounce, multiple bounces in the scene, and then based on those bounces they render the scene. Okay, so yeah, it's expensive for the hardware. In fact, it's so expensive. Let me just complete the yesterday's session, because yesterday's session was a little bit stretched, so I was not able to complete it fully. Okay, there are some more things which you need to understand about that session. So let me just again share this screen. And also whoever is watching this, please make sure you have the receive resolution of 720p, because that is important. Okay, so I'm going to first let you dive into my inspiration of why and when I created the first ray tracer. Okay, so if I talk about this video, this is a super cool video, and I want you guys to look at this. So somebody again from scratch was building a ray tracer, and it's earlier in 2011. So so somebody is just instituted libraries and started building the ray tracer, and he kept on building on C. So we could have done the same thing on this blue interface as well, but for the convenience I chose dev C++, which is the same thing, just not the blue interface. Okay, so somebody is again building. So you can imagine there's a lot of code in ray tracers, but the final outcome will definitely shock you, because it shocked me when I saw it. It sort of opens my brain about graphics and thinking, oh, how is this possible, or something like that. So I was very amazed by all this coding and the final outcome specifically. So this code is in very high speed, but when finally it completes, you can see one single line is started tracing. Okay, so it's very slow, as you can already imagine. It's drawing pixel for one single line, then it goes to second line. As you can see, this is how ray tracing works. Then simultaneously a few lines are being drawn, and then you can see finally a picture emerges from that ray tracer. And similarly, you can see now he is rendering too fast, means he is basically capturing the images over the time. And now you can see the final outcome of that ray tracer, and it's just blows your mind because everything in this scenario, everything in this scene is created from just code. There is no visual graphic present here. It's nothing drawn by an artist. And when I saw this, there are transparent things, there are shiny things, and these shiny and transparent things are hard to code with rasterizers, but they are the essence of ray tracer, because ray tracer is actually mimicking the way how light works in the real world, and it's the accurate representation. So it's one of the coolest thing I saw in the world of coding. So then I decided to build my own, and then in year 2017, I think, I built my first ray tracer. And the ray tracer you saw yesterday was a smaller code of that. So as you can already imagine, it's yeah, it was not possible in one iteration. So if you didn't get the ray tracer code in one iteration, it's okay. It's very natural, and nobody can write a ray tracer in one iteration. Okay, so again, I faced some iterations as well. I was trying to find the photos of mine. I had a ray tracer album, so let me just, oh yeah, exactly, I got it. So I have this ray tracer album. As you can see, it was not done in one iteration. The final outcome is this. You can see the images, the quality, they actually look subtle and they actually look really good. But previously the images were like this, and then the images were like this, and you can see it's the light intensity is just one, you can say one out of 100. So it's just hardly lit. You can see the binary images which I computed. You can see the errors which I made during the process of creating that ray tracer. So there were plenty of mistakes that I did and all those. So, and even the mistakes were beautiful. So yeah, that journey of creating a ray tracer. But I also coded a rasterization yesterday. So this session was about to go with the rasterization, but I find out that a lot of people were not very comfortable with even the ray tracer. So the rasterization is going to be a little harder. Okay, rasterization involves a lot of alien math, because ray tracer is very physics oriented, and you know what is happening or why is happening. We are calculating the light bounces, that is easy. But in rasterization, there is projection involved, there is Bazerham equation involved, and so many things which you might be unfamiliar. So I coded yesterday, last night, this project. This is my first you can say this is my first rasterization. I always wanted to code a rasterizer, but I never get time. Thanks to you guys, I got time to code one. So this is a rasterization code which I made last night. Okay, yeah, I hope it works. So let's see the outcome. I'm going to compile, and it draws a triangle on your screen. Okay, and you can definitely so you can see the vertices are drawn by this star, and the filling of the triangle is being done by these ones. You can see the outcome. So this is the final outcome, and this is a binary triangle. We are not rendering it very fully, and again, it's this code still needs a lot of work to finally compute the final image instead of this stars and dots. Okay, so but the idea of this code is basically it can be done with any sort of display, any sort of rendering method, mechanism, or whatever. The code remains the same. The fundamentals of programming remains very same in any way. Okay, so this is the code, but I'm not going to show this one today. I'm going to deviate from our structure and going to work on simple things. Like if you like, somebody told me that they find Unity overwhelming, so I'm going to talk more about Unity today, and not just Unity, a very specific, a very mathematical topic which a lot of people get wrong, even in the who are in the industry for 5, 6, 7, 8 years, get this topic very wrong, or maybe use smaller hacks, because it's very easy to get some sort of hacks in this field. So I'm going to talk about easing functions and interpolations. Okay, so what are easy functions and interpolations? I'm going to show you a demo. You can, I hope you can see already my screen. So suppose if I have several candidates, or several game characters, or several you can say data points, which are competitors and which are moving in one line. Okay, but that motion does not always has to be a linear motion, which means that motion of thing does not supposed to be always equal at every single point. It could deviate, it could start slow and move faster, it could start faster or move slow. So here is an example of that simulation. So if I tap, you can see, okay, you can see some motion, some balls are going faster, some balls are going slower. Okay, so now there is a fun fact that each and every ball, all these how many 3 and 3 6, all these 6 balls are going to take exactly same amount of time from reaching this A position to B position. Okay, these all these balls are taking same amount of time regardless of the motion, but the motion of all these balls is different. Okay, it's taking some are taking much time in the beginning, but going fast in the end, and so on. Okay, so this is called interpolations and easing types. So we have coded several easing types here, like linear, ease in, ease out. Okay, so what is ease in? Ease in means slower in the beginning. Okay, in means beginning and out means end. So slower in the beginning, and ease out means faster in the beginning but slower in the out means end. And there are power 3 and so on. So we are going to talk about what are these, and how many types of interpolation and so on, and how to visualize them, and these sort of stuff. So again, we are also going to take up you can say grand perspective view of rasterization, because this topic is also related to rasterization, which I coded a program, as you already saw the triangle I was drawing. Okay, again, I must also show you the triangle drawn by a rasterizer, usual rasterizer. So if I talk about raster triangle, usually you will get images like this. Where is my lucky triangle? Something like this. No, not exactly, but raster triangle color fill. The ideal triangle which I want to draw is looks like this. Okay, but I'll produce this image. Okay, so now let's understand what is happening in this image. Okay, if I talk about this image, why this image is so important, what is the goal, or what does this image is trying to say to us. Okay, it's basically telling us this is a triangle, and triangle is the simplest or the most fundamental form of rendering which you can do. Okay, whatever you see on your screen is basically made of triangle. Okay, you can make any shape based on triangles. All right, so here is a triangle, equilateral triangle, and what is cool about this triangle, that each vertex, that this beginning point, this beginning point, and this beginning point, all the 3 points, or all the 3 starting points of triangle are consist of different colors. Like this is the red vertex, this is the green vertex, this is the blue vertex, but and some sort of interpolation is being happening in terms of color filling. So whenever we are doing the fragment rendering, we are rendering the color based on the vertex color, which means interpolation. Okay, and also there is a fun fact. There are two types of rendering. A lot of people don't know about this. Okay, so there are two types of rendering. There is linear rendering and there is gamma rendering. I'll show you the setting in Unity for a second. A lot of very experienced developer even mistake with this or don't understand this fully. Okay, so yeah. Okay, so if I go to other settings, you will see color space. There is an option and it shows linear and gamma. Okay, so what is the meaning of these linear and gamma? I'm going to tell you here. Okay, so for example, in this spectrum, you are looking at an image and you are thinking that okay, it's a linear interpolation, because you can see equal part of green, equal part of red, and equal part of blue here. Okay, that's what you can see. Okay, you might think that and ideally it should be a linear interpolation, but this image is actually manipulated. This is a gamma interpolation. And what is the difference between the linear and the gamma one? A color space. So your eyes are more sensitive to some colors than others. So if we, for example, show same intensity of red and same intensity of blue, your eyes will more notice the red than blue. Okay, so even though mathematically we are showing the same intensities of the color, you'll register more of red and less of blue. So this is linear. Okay, so what is gamma? Gamma is basically we sort of adjust based on your eyes, the understanding of your eyes, human eyes. Based on that, we for example, if we have to show two colors, I'll now show red a little less intense and blue a little more intense, so that they look equal to eyes. Instead of being actually equal to mathematics, they became equal to human eye. Okay, so that's that when we adjust for human eye, that is called gamma color space. Okay, so I hope you got some sort of understanding of color spaces. Okay, so this is supposed to be in the middle, but when you render this sort of triangle, you will notice that red is a little somewhere like this, and blue is here, green is here, because red is more red is registered more by human eyes. And if you render this triangle in linear space, it will have that sort of problem. Okay, so that, yeah, this is a perfect example. You can see the red is a little overpowering blue, you can see, but I can totally tell you it's linearly rendered. Okay, so yeah, that is what I wanted to tell you about colors, sorry, about rasterizer. Okay, so if I also show you any 3D model, okay, you can see these are made of these squares, okay, or these rectangles. Okay? These rectangles are called polygon, and ultimately these polygons are either made of rectangles or triangles or simpler shapes. Okay, with the combination of these simpler shapes in 3 dimensions, we basically create any model, which I already mentioned you in the computational thinking session. I'm just repeating. Okay, so if I talk about this, so basically when the same way you draw one single triangle on screen, the rasterization process is very same if you want to draw a million triangle on screen. It's just iterate for each other triangle and draw each on the position based on all the factors like texturing, like emission, like lighting. Okay, so yeah, that's it for rendering. And there you may ask that when it's good to use the rasterizer or when it's good to use a ray tracer. So if I talk about Pixar level movies, like for example, if I tell you Pixar movies, ray tracing. All right, so you can see Okay, it's very low quality picture, but HD. Let me just type HD. No. All right. So Pixar uses Pixar is known for this. In fact, okay. So Pixar is basically uses a very high quality ray tracers, and they are very detailed. They use very detailed scenes with very detailed ray tracing and all that. So this is why their scenes are just more realistic and looks much more detailed. Not detailed in terms of accurate lighting. Okay. Details comes from the creation of the scene and all those, but here you can see a paper specifically on Pixar. Okay, how the ray tracing works. So in movies where the graphics are not real time, okay, these graphics are not real time. Okay, these are basically not by not real time, I basically means that these are 1 frame a day, not 20 or 30 frame a day. Okay? To play a game you need at least 30 frames a day, sorry, 30 frames a second. Okay, a single second rasterizer is basically rendering 30 frames. Okay, but with ray tracing techniques, with so much detailed ray tracing, and we are calculating multiple bounces and all that, uh, these pictures are rendered by something, the machines, they basically have the whole farm of machines. They have places in which hundreds and thousands of computers are there, and they have just one job: render images. Okay, and they all work simultaneously and produce movie scenes, which means somebody render or arrange the scene, and the final outcome is done and is produced over months. Okay, previously it used to be over months, but now I'm sure the ray tracing is even becoming real-time science. So even with ray tracing now games are coming, which means again, not everything in there is ray tracing, but a lot of things are ray traced. Okay. So which means a more accurate, right, and all, but it takes much more performance, much more performance than rasterization. So whenever we are talking about interactive graphics like games and real-time graphics, we are talking about mostly rasterizer. Okay. Now when we are talking about ray tracer, we are talking about movies or non-interactive graphics where we can give time for a frame to render. In case of very detailed frames like these, it could take a single day. If you render to render just one picture like this, it could take a whole day on your machine. Okay, so it's very natural with ray tracers. So yeah, this is, I think, all about difference between ray tracer and rasterization, which I want to talk you about. So now let's talk about the easing types. Okay, so again, you may already know me, so I'm going to move the slide next. Okay, so this is ease in sign, which means it follows a sign, but is ease in, which means it's slower in the beginning but faster. You can already see the graph. So in this graph, where are the values? This is basically the value graph, which you can say y axis. This is basically on this, and this x is the time graph. Okay, so you can see it's slower, or you can see the value is not very increasing in the beginning. If you talk about this time, the values increasing very less, but later value is increasing faster. Ease out, in the later part the values increasing slower. Okay, so ease in and out both, which means it's slower in the beginning, slower in the end, and the value is increasing in the middle. So middle slope is very steep. Okay, so yeah, similarly we have all sort of functions like ease in, out, quaint. This is a quadratic function, and it basically very slow in the beginning and very slow in the end, but very fast in the mid part. Okay? So similarly, we can also create bounce functions. All right. So these gives the effect of bouncy graphics and all. Okay? So let me just tell you how to we create this. And again, we since we have two axes, one is time and the other one is obviously the value. So we have to calculate time very accurately. Okay, we have based on the time everything will work. So how do you create a timer? If you know Unity or C# programming a little bit, sorry, there are interpolation methods, sorry, there are ionerators. Okay, and these ionerators are functions which let you introduce delay. Okay, which means these are not running off on the main frame, the main thread. These are running on the separate thread. Okay, and they basically have the capability to not follow the time of all the time cycle of program. Okay, so difference about a normal function and a inter enumerator function is basically you can stop in between the execution. So I can introduce a yield statement and it will yield, it will stop executing in between, it will wait for that delay time and then execute later. Okay, so we have to calculate and sorry, we have to calculate as
Avi, if I can ask a question here.
yeah, sure.
So, enumeration is something that we have been studying in C++ and other programming languages also.
Yeah.
So, this I enumerator is something related to that. And what does that I stand for? If you can please clarify.
Yeah, surely. So this I enumeration is again the idea is to introduce a delay between execution. Okay, so you can specify the amount of delay in various ways. There is a yield function inside this which allows you tons of options like yield till something is not loaded. For example, if you are loading some website, you can use give us the name of the data loader and it will basically stop till the website is not loaded and then processing after the website is loaded. One functionality is that, or you can specify number of second, or you can specify even the next frame. Okay, which means stop till then the next frame is not there. Okay, so you can make it equal to the update function and so. And I enumerator in this is just a naming convention which Unity C# is following. Okay, so it's this I is I have no idea that why they choose I, but it's just I believe it's just a naming convention which they are following in this case. I hope that answers. Okay, so I know that you guys are already doing a lot of Unity sessions. So, but I'm going to take a very less time because Unity is a very good rasterizer. Okay, when I talk about Unity is a rendering engine and a physics engine, I basically means what sort of rendering engine? It's a rasterizer. It's not a ray tracer, though it does support some hacks through which you can do some sort of ray tracing, but it's mostly a rasterizer. So I'm going to take a look into this rasterization method or how Unity does its rasterization tricks and going to tell you something about it. So yeah, this is basically the hold on, this is basically the Unity's first session which I do. So let me just do that. I know you guys have already getting trained on Unity and getting introduction to Unity, and you might not need it, but let me just do my bit, and I'm just more comfortable if you understand the way same way I do. Okay, so we have here a very simple scene, the very first scene which you might already get in Unity. If I right click on here, again, do I need to guide you about the scene and all that? Because I'm going to skip that. So this is scene panel in which you basically arrange the objects by manually. Here is the outcome of you can say the output, visual output window. There is also a textual output window which I can show you if you go to here and basically select console. So sorry, Where is console? Window, there must be a console. There's a shortcut as well, command shift C. Okay, so control shift C is a shortcut for console, and you can drag and drop. So this console is basically the textual output, and this is the visual output window from where this visual output is coming. So if I create a cube, 3D cube, all right, you can see something here already. Okay, you can see there is a cube here. So let's try to understand. Here this cube is represented here, but the same cube is drawn here. Why? Okay, the answer is in perspective to camera. Okay? So this is the camera, and camera is giving us output in the game window. All right, so camera has a task. Camera is a virtual camera. It's just have the name like a camera, and it is working like a physical camera. You can already notice camera has some sort of these triangles coming out of this triangles are called what are they called? I just forget the name. Awesome. These triangles are called the frustum actually. Okay, so these in this frustum, whatever is inside this frustum is being drawn, and whatever is outside of this frustum is not being drawn. Okay, so let me give you a simple perspective of this camera projection raster. Hold on. There is a very good two-dimensional example which I'm here trying to look for, but even if I don't get it, this will do. This is a three-dimensional one, but it will, I think, confuse you a little bit. No issues. Let me try to make you understand without any image. Okay, so how this is working is basically the camera can see only what is inside this white lines frustum. I have controls to reduce or increase these white lines. For example, there is something called field of view. So if I narrow the field of view, you can see this angle between, you can say if this line is the center, the angle between both is reducing. So the field of view is, you can say, reducing. It's works like a zooming effect. Okay, you can already see the in the output window, this cube is zooming in and out. All right, this is the effect of that camera. Okay? So by default the FOV, field of view, is 60. There is also a field called far. I can reduce this far plane and you can immediately see the effect. So for example, if I type 100, so you can see this is reduced. The edge of these are reduced. You can also drag and do this, so it's changing the field of view. I don't want that. So we can also reduce it so less that it stop rendering this cube. Okay, so if you notice it now, if I focus on camera, so you can see here is our the cube is not rendering, and the reason why cube is not rendering, because the far camera can see is end here. Okay, just before the cube. Okay, if I see what will happen if I do this, okay, the cube just appeared. Okay, you can see the outcome in this smaller window here somewhere. Okay, so the cube just appear out of nowhere. And why this is happening? Because the frustum is basically letting this happen. You can see the half of the cube is there. If I rotate, this will look even more apparent. You can see the half of the cube is being rendered. And why this half is rendered? The reason is it's half inside this boundary. Okay. So this boundary controls what camera can see or what camera cannot see. Okay, so it's showing you the intersection of what possible. Okay, how this camera is working? This camera is basically a very good rasterizer, and this cube has some geometry. If I try to show you, this cube has these sort of geometry. You can already see triangles on this cube, right? Like this. These are smaller lines on this cube. These are smaller triangles on this cube. You can so a normal cube, standard cube, has 24 you can say vertices and so many triangles. Okay, so yeah. So if I talk about camera a little more, if I can choose to move camera left or right, and my perspective of the output window will move, because output window is solely dependent on this camera. All right, you got the idea a little bit about camera, that how camera works, but there's one more thing which is important. Okay, so we have to understand the update cycles. So for example, if I add something on my cube, I'm going to create a C# script and I'm going to name it cycles. All right, where it is, yeah, it's just opening. Okay. I created a script, and this is more about showing you how the this output works, this textual output, how it's going to work. So if I double tap that, okay, what I'm going to do, I'm going to add some code here. For example, there is a start function in Unity, and there is also an awake function in Unity. So void awake, all right, and they both have almost the same job. Okay. So if I do this debug.log awake and debug.log start. Okay. If you may notice, if I run this script now, what will happen? I'll get a log. Oh, sorry, awake and awake, because I have written both awake. I must have written this at start. I'm really sorry. If I go back here, turn this off, turn back on. All right, so I have not chosen collapse or clear on play. Hold on, clear on play. Okay, so yeah, the output is awake first and then start later. Okay, so why so? Because awake is always called before start. Okay, so whenever you are doing something which is dependent on the other script, some other script, so make sure that script is initialized first, because otherwise the values you will get will be very wrong. Okay, so all the initialization happens in awake because awake is called the first. Okay, and everything which is dependent on the other script, for example, for beginning you need to access some script. So for example, get component something something, or some other script you pass in there. So that function should happen in start, not in awake, otherwise you will get into trouble. All right, because awake is called first and start is called later. So make sure you follow this hierarchy. Okay, you got the idea of what is awake, what is start, but there is also something called on void on, hold on, void on enable. Okay, so void on enable and void on disable calls every time when the game object turns on or turns off. Okay, so for example, if I turn this cube off, you'll get the feedback of void on disable, and if I turn it on, you'll get the call of void on enable. And by the way, how you get this calls? Okay, does anyone know how do they get this call? How? So the answer is, how do you get this call is the mono behavior class. You are inheriting mono behavior, and that will allow you two things, tuning a lot of things. Two important things out of those is why you inherit this is, if you don't inherit it, you cannot make your object or you cannot make your class attached to a game object. For example, if somebody sits on hierarchy, this is called hierarchy, and if there is an object in the hierarchy, make sure, let me remove this, oh, hold on, let me remove this script from here. Okay, so if I want to add my script to this hierarchy, I have to make sure this cycle script has the mono behavior. If it does not have a mono behavior, I cannot drag and drop on my object and it could not be able to attach like this. Okay, so I have now cycles. Okay, and to whatever object it represents, it's added on, it gives me callback from that object. It basically, Unity is basically trying to tell us through this mono behavior class that what is the state of our game right now, or what is the state of our object right now. Is it on, is it off, is it getting on, is it getting off, using on, disable, on, enable functions. And there is a very cool function which is called update. Okay, a lot of people with good amount of experience get confused with what is update, and specifically there are three types of them, like update, fixed update, and late update. So I'm going to talk about a little bit of what is update. All right, so update is nothing but Unity's way, or mono behavior's way of telling you, dude, I'm going to take a picture, make sure you are ready for that picture, make sure you are smiling, make sure your tummy is in, and all that. Okay, so it's basically Unity's way of telling you that I'm going to click a picture and make sure you are ready for that. So what do I mean by that? Let's debug.log, and here I am going to say update. So you have to notice that what happens in the log after I do this. Okay. So if I play the script, what will happen? You can see I have added collapse. One time it's called start, one time it's saying okay, I am started, and now update is calling each time. Okay, you may ask why it's calling so many times. Okay, because the picture by Unity is being clicked 1400 times per second. Okay, which means the whole rendering process which I described in the computational thinking is being happening in 1 second 1400 times approximately. Okay? This is huge. All right, so why this is happening so many times? It's the way of how interactive game engines work. There's something called render loop. All right, which means you might remember that in the previous sessions in which we were rendering images, and yeah, by the way, I forget to show you the some of the outcome of that ray tracer which we built. So if I go here and if I show you this render, this beautiful picture you can see here is being drawn by the code which we created yesterday. Okay, so but this is just one picture, which means I cannot show any sort of motion. You may already know what is a video, and video is not just one picture. Video is thousands of picture and arranged in such a way that it looks at least more than 12 fps. Okay, so that it looks like a continuous motion. So if suppose I put all that code in a loop, in a render loop, okay, we call that loop, so that sort of loop a render loop. So if I put all that code in a render loop of generating image, then I could show some sort of movement, because in one image I'll show like this, and in the other image I'll show it moving like this. Okay, got it? So I can show then some sort of movement with these objects if I do that all process in render loop. You got my point. And that is why Unity is creating a render loop, and you are getting update in this render loop. That render loop is about to begin. Okay, so now there is a pause button, and let me know that what that pause button does. Okay, so if I pause this, let's see what will happen. Start called 1, update called 1, and you can see there is no FPS counter going on. It's just stopped wherever it was. Okay, which means right now the Unity is not rendering anything. Okay, this last image is created, but it's just one image. So if I want to move the cube, it will create some more renders. That is the only way to move. Oh, it's creating on the back end, but it's not showing the number because for some reason I don't know. Okay, so let's talk about what will happen if I press this button. It just render one more frame. Okay, it's like it just clicked one more picture. So if I tap one more, it's clicked one more picture. If I tap one more, click one more picture. And you can only show motion in multiple pictures. So for example, if you move and there's no picture being taken, you cannot rotate it. All right, you cannot move it. You cannot, you may move the virtual object, but the outcome, the effect will not be visible. So this is why whenever I want to do any sort of code which is related to motion or something, I have to do in some sort of update function so that it sync with the camera or clicking technique, so that it sync with the camera clicking timer. Okay, so I'm going to do the same. Let's me add something called transform dot rotation, rotate, and here I'm going to define some sort of uh, public vector 3 rotation. All right, transform dot rotate. Here I applied rotation. All right, what will happen after this? I'm going to play this thing. Okay, so yeah, it's already running, but nothing is happening. All right, why nothing is happening? Because there is no number here. So since we declared that public, it's there in the inspector. So if I apply some value, you can see the cube started rotating. All right, you can see the outcome of this our cube. Got it? So now let's see what will happen if I simply pause it. All right, now I don't want to render the cube till I press this. Okay, what happened? It's just moved a little, right? And you know that from where it's moving from here. And I can also tell how much it's moved. It moved 5 degree. So for example, if I made it 90, you'll notice that the cube in next render moved 90 degree. Okay, so since it's 90 degree moving and this is a perfect cube, it will not look, okay, it will not show any movement because it's just moving accurately. I'm going to move it 45 degree. You will see now. Okay, you saw it's moved half, it's moved half, it's moving good amount of movement, but it's moving only when I'm pressing this button, because then Unity is telling us, okay, next picture, I have to click a next picture, make sure you are in the right condition. And what is the right condition for us? Move 45 degree. All right, in the y-axis. Got it? So that's how Unity's render cycle works, and this render cycle is very, very important. Again, for the dependencies, so all the updates happen first and all the late updates happen last. Okay, so for example, if you like, it's the same concept of awake and start. Do all the dependent work on start, because otherwise if you do on awake, maybe the other object is not initialized. So whenever two objects are dependent on each other, make sure you are updating the dependent object, or dependent object on update late update. Okay, so there are 3 updates: void late update, okay, and void fixed update. These are 2 more render loops. These are same render loops, and the idea is same, that Unity is telling you, I'm going to take picture, make sure you are it. Okay, so we have these 2 render loops and fixed update.
Avi, is fixed update meaning that it will happen at a fixed interval or something like that?
Exactly, totally awesome. So fixed
Okay,
update
thank you.
is totally, you are 100% correct. It's a fixed interval. Okay, what is this fixed interval? You can specify this fixed interval in Unity setting, but by default the value is 0.002. Okay, maybe if you change it, the value becomes something else, but by default this value is this. What does this value really mean? It means this many milliseconds. Okay, in 1 second you can divide it by 1, you will get how many frames will be rendered. So for example, if I copy this number, okay, and Unity has a very good calculator built in. So if I divide by this number and press enter, you will get 500. Okay, so 500 frames are being drawn. 500 is the right number? I don't think so. 0.002. Yeah, I think it is. Okay, so by default this render this fixed update render loop is 500 and it's fixed interval. Okay, so you may ask that if this is fixed, update is fixed too, right? And the answer is wrong. Update is not fixed. As you may already know, if there are many things in the scene, maybe in the photo clicking process, because photo clicking process is not very easy. You may already know the process. I told you about rasterization, that there's vertex processing and there is fragment processing and there is so many things. Okay, so it takes time. Rendering an image takes a little bit of time, very small number of time. Okay, and I'll also tell you how to read that time or how to visualize or look at that time. Okay, so it takes a very small amount of time, but it takes time. Okay, which means another render loop can only happen when first is finished. That is true. Okay, so whatever the time, it's dependent on whatever the time previous render loop took. Okay, for example, if previous render loop took 0.00 sorry 0.001, okay, the next call will happen after that amount, and maybe in next frame you are doing some complicated math, or you are rotating, or you are for making some object visible, invisible. So that new object which is introduced, that needs to be rendered in the previous image, which means to render this now this image rendering is going to take little more amount than the previous frame, and that will affect the timing of this render loop, which means it will now take 0 again 0, maybe 2, maybe, or maybe 2.5. Okay, so now you can see this render loop took a little less time and this is taking a little more, but so this make it not very fixed. Okay, which means this is not very fixed. This is dependent on how much time the render cycle is going to take. But and just after completing render cycle, the next loop is started. But the fixed render fixed update is fixed because you can do all sort of physics based calculation. So how physics based calculation works, they are not dependent on the time cycle, they are dependent on where my object was in the previous position, so and what forces are on my objects. So I have to calculate where it's going to be in the next frame. Okay, so if you render these sort of calculations in update, it's going to be jittery. Okay, especially on the effect will be more noticeable if somebody has a very slow computer. Okay, because the render cycle is going to take a lot of more time and the physics calculation will look jittery. Okay, so if I show you an example, or maybe I think there are good examples out there, so let me just try to give you perspective. Fixed versus all right, I'm just trying to give you a little bit perspective. No, this video has nothing, no issues. You can, I think there are images as well. Fixed. I'm not able to find some very good example, but the idea, I think you get the idea. It's very simple. This one is dependent on the render cycle, so some frame could take more time and some frame could take less time, but this is very fixed. The interval is fixed between this. Okay, and you can change that interval in the settings, but it's by default this number. Okay, it's called after this one. So this is more used for physics update. Okay. And what is late update? Late update is for dependent object. This is called after these updates are finished. After your after your update is finished, all the updates are finished in the scene, then late updates are called. For example, if you have a camera following a player, so you have to make sure that player has taken the position. After that, the camera should take place. Okay, if the camera will take its position first, and then player could move somewhere else where the camera is not targeted towards. So camera is dependent on the position of player, in especially in case of following cam. Okay, so the all sort of following camera code will be go in late update. So it's good for you can say follow or dependent. Okay, so all sort of these sort of codes are goes in this late update. Okay, you got my point. I hope now you understand the rendering cycle. And
Just a small clarification, please.
yes, yes,
So first the updates will happen,
yeah,
then the fix update will start happening
yeah,
at regular intervals,
yeah.
and then the last update will happen along with fixed update or at the end.
So fix update does not follow any I mean, as you can already assume, it does not follow render cycle. It keep happening at the fixed interval. Okay, okay. And the late
Okay,
up,
so
yeah.
that means
So
it can happen within the update also.
yeah, so yeah, that is very true, which means if the timer of this fixed update is finished, it could happen before update as well, it could happen after update as well. So it's not it does not fit in the line, but update
Got it.
and late update are always fixed, that only after update is finished the late update will happen. Because you can say somebody has written code, whoever is doing the rendering has written code. Okay, first I'm going to write update and later I'm going to write late update. But fixed update is not in that boundary. It could happen earlier, it could happen later, based on how fast or slow your update cycle is. The arrangement could differ. Yeah,
Got
so
it. Thanks.
so okay, so we have this sort of an understanding of how the render cycle works. Now we can build our this scene. Okay, so I have already built. I'm not going to do coding again, and we don't even have time for that. I did that code in one more session on Nikhil Malanka's channel. So Nikhil Malanka is a very great YouTuber. You can check his videos on his channel. We did a charity stream in which we were collecting some money for charity, and in which I built this scene which you are looking at right now. So I'm going to go over the code. This code is called motion control. I'm going to talk about a different sort of motion. So I have taken the position of all the objects like transform references. Okay, then I have the start position and the end position. So it's a one-dimensional value which basically does the job. So for x it's minus 10 to plus 10. Okay, so the beginning point is minus 10, the plus the end point is plus 10. So that is the area in which we have to interpolate. Okay, so whenever we tap a button, you might already know after these sessions that how to take button. So if we are getting the input from mouse left button, we are starting this enumerator, starting this delay function. Okay, so in any enumerator, as I already said, the most important thing is the delay. Here is my delay. Here I'm delaying based on end of frame. So what is end of frame means when the update is finishing, which means this render loop is going to work same as render loop. For example, this difference is going to work as same as one render loop. I could have also choose different settings for yield functions like yield, return, new, and wait for seconds, which is very commonly used. Wait for seconds, and I can introduce a delay. This is very useful in, for example, if you are doing sequential animation where one thing have to happen, then next thing. For example, a text will come, then image will appear, and something will come, like a logo animation or something. So in that sort of scenarios, this is very useful. Okay, you can specify differences between each thing to happen in this. This is one of my favorite functions in Unity, I must tell you. Okay, because it gives you a lot of options. Yeah, so I'm using this function, and let me tell you how I'm doing that. Okay, so I have created a tick. Tick is basically a simple variable which will iterate, and I have created a percentage. This is a percentage value. Okay, and I have decided my animation time will be 2 seconds, which means all the balls from here to end, from beginning to end, will take 2 seconds to interpolate. All right, which we have decided here. So now let's see, I have created a while loop, and while loop will run until this our timer, the ticker, is less than this value, which means 2 seconds. This is the same animation time. Okay, here I'm doing, I'm calculating a percentage value, which means how far we are, how many ticks we have did. Okay, now this is one of my favorite variable, and this is the most misunderstood variable of Unity. Okay, this is the most useful but most misunderstood as well. Okay, so I'm going to talk about this. Remember I told you that I'm going to give you that how much time one render cycle is going to take. So this is the variable responsible for one render cycle. Okay, for example, this variable is nothing but the value of what time it took to render previous frame. Okay, whenever Unity completes the cycle of one frame, it puts the value of how much time I took to render this frame in this variable, time dot delta time, which means this has a simple value. For example, if the frame rendering take 1/10 of a second. Okay, so if it take 1/10 of a second, if you add 10 of these, you will get 1 second. Got it? It's a simple idea. So for example, if I keep on adding this number, okay, into itself, it's going to be 1 second. It's going to take the value of 1 in exactly 1 second. Okay, you got my point. It's a very small number. Okay, and in 1 second it's going to be 1, because it's basically telling you how much time it took to render previous frame, and in rendering the next frame it's going to take again smaller time, in rendering the next frame again smaller time, and in the period of real physical 1 second it will be rendering no matter how many frames, but the total amount of seconds will be 1. Okay, so that's what I am checking for. This is the only way to check 1 second in Unity. Okay, so here I'm adding up this my value, incrementing my value by this factor, this small number. Okay, I'll also, for your convenience, I'm also going to print this small number, because this is again most misunderstood variable of Unity, as I already told you. So I'm going to print time dot delta time, and there is also time dot fixed delta time which you can get, which will give you that fixed value. Let me just print it for you, time dot, and I'm going to write a message fixed, okay, so that you can know that it's fixed one, and then I'm going to say time dot fixed delta time. Got it? So now I got a smaller value. I'm just printing it for you guys. Okay, so yeah, and how I'm calculating this tick, so it's going to be basically percentage between this and this. So let's imagine what will happen if that tick value goes to it goes equal to animation time. As I already said, this is counting how many seconds are passed, okay, in this tick variable using this method. So for example, if tick is equal to animation time, this function will return 1. All right, if tick is 2 and animation is also 2, it will give me 2 by 2 1. If the tick is 0, which means nothing is passed, and animation is this, it will return me 0. All right, so anything in between will give me a value 0, between 0 to 1. All right, and in linear fashion. So I'm getting the value of this percentage 0 to 1. So if yeah, this is saying 0 upon 2 equals 0, and 2 upon 2, which is the max value which can be reached, equal 1. So here I'm normalizing this tick variable, and I'm getting value 0 to 1. I'm sorry, I think the text is too small, right? Let me just make the text bigger for you. How do I make the text bigger? Why do they don't make it so easy to make text bigger? Can I make text bigger? There's so many settings, but there's no direct function to make text bigger. Make text big in Visual Studio. Okay, how do I do that? Okay, तुम बताओ भाई. Project. क्या करना है? Hold on. It's a create a text file. Text size. I'm sorry, it's just taking a little time. Tools, options, and then environment fonts. Okay, tools, options, then environment. There is environment, and then font. Where is font? There's no font.
Uh, is there anything called environment there?
Under,
Tools,
yeah,
options.
environment is there, and
Yeah. Under environment, fonts and colors.
got it. Yeah. Okay. Yeah. Now I'm making the size bigger. Yeah, it's much more better. Got it. Awesome. So we reached so far. Okay. Yeah. So now you got the function. It's basically normalizing. It's telling you in 2 seconds how much time is passed. Okay. If, for example, nothing is passed, it's going to tell you 0. If 2 seconds are there, the ticker has counted 2. It's going to give you 1. Okay. How much percentage of time is being passed? Okay. This variable is going to be very, very useful. Okay. Now I'm calculating how the movement will happen. So for example, this is already giving me the linear motion. This is giving me, this percentage value is giving me exactly linear between 0 to 1. If I have to calculate ease out, I have to implement the sine function. So sine times pi upon half. Okay, so sine times pi by 2. So creating the percentage value and multiplying that by sine and creating, because if you look at this chart, let just show you, without that there's no point. Yeah, hold on. 50. Okay, so ease in sign we are talking about here. We are talking about ease out sign. Okay, so you can see we have to create this curvature. Okay, we have to actually create this curvature, which is possible because of sine value. So here we are, you can see this, you can call this as the half of the sine function. Okay, the sine will complete like this, but this is the half of the sine function. This will go like this, then this, then this. This is how sine function works, but this is the half of, so that's what we are calculating here. Okay, whatever the percentage value is times 2, we are multiplying by pi by half and then putting into the sine function. Is same, but in the different direction, you can say it's the cos function instead of sine function. Okay, so here we are, what we have did 1 minus cos function, which will basically, if we only do the cos function, it will give you something like it will give you something like this. If I can draw again, where is the marker which we had? Draw, I downloaded yesterday. Where is that marker? Epic pen. Sorry. No setup. Okay, epic pen. So for example, if I don't use minus sign, how the cost function is going to look like. Yeah, choose a patla. Cost function then will look like something like this. Okay, if I do 1 minus cos, then it will look like this. Got it? So that's what I am doing here. Okay? And cos function will go like from starting here to here to here to here, and the sine function will go like here to here, as you may already know. All right, so you can already see we have this beginning of this cos function like this, but we did 1 minus cos, so it's going to be like this. Got it? So I hope that explains. Here what we did, the same thing, 1 minus that cost function equation. Let's see how exponential works. Exponentials are simple. If we multiply double instead of ones, so percentage time percentage. So let me, where is the pen? Yeah, this one, right? Yeah. So where is the pow exponential? I think in this one exponential is not mentioned, but let me just tell you. So suppose automatically rolled. So suppose by linear it takes this much time. The linear curve is like this. It's not presented in here, but the linear is like this. And you know we are incrementing with the this value, this previous this percentage value. So if I talk about this function, percentage times percentage, so what will basically happen if only 1 percentage value we are computing with? The 2 percentage value are going to work like it's hold on, the marker is already bigger. It's like it's growing this way. Okay, it's this sort of curve which it will take, and there is also more steeper curve which will be created from like this. Okay, which will going to be power 3. So as you can already see, these 3 curves which are being drawn and which are representing these exponential values. All right, now lastly what we have to create is this curve, this other curve, which is smooth move, which is smooth in the beginning, smooth in the end. All right, so how this is created, how do we get smooth in the beginning? So again, this is percentage times percentage, but to get smooth in the end, we have this other value, which is 3 minus 2, which is 1. Sorry, this will be calculated percentage times 2 minus 3. Okay, if I do 1 minus 3, that is going to invert that in the graph. But if I am doing 3 minus 3, it is going to invert twice, which means in second it will invert the other way, the positive way, and in third it will invert again in the negative way. So something like that, what I am trying to represent here. Okay, now how I apply, I have created a linear function here. Okay, now see, let's see what is this linear function. So for this linear function, I have added the start value, end value, and percentage value. So as you may already know, Unity has a function of its own, which is called vector3 dot lerp. Okay, and what this function takes, it takes a, point B, and float t. Okay, so a lot of people don't know that what this float does and what does this float value actually mean, but I'm going to a little bit dive into that. Okay, so that float value is actually percentage value, and that t is not a very good idea. So this function basically returns whatever the float value is. So for example, if I give in this function, hold on. So if I start giving in this function the values like from 1 to 100, and if I give the float value 0.5, the function will always supposed to return me 50. Okay? suppose if this is 0, okay, then this function is always supposed to return me 50. Okay, that's how it works. It returns you percentage between A to B. All right, so what formula we are using to get the percentage between A to B? We are using basically whatever, yeah, hold on, yeah, we are using A, whatever the start value is, plus B minus A times percentage, which I'm representing as P. All right, so if you imagine the percentage as 0, so what will be the outcome? Outcome will be A, whatever the A is, plus B minus A, which means some value, the difference between B and A. This is the actual distance which we have to travel, you can say. Okay, A in the, which means beginning of the spot, plus the distance which we have to travel. So this is B minus A is defining that distance, and times the value, the percentage value. If we have to suppose travel 0, this whole idea will become this whole will become 0, A plus 0, and the outcome will be just A. Okay, if this becomes 0.5, so it will give you A plus 0.5 of that difference, which will, it will point you somewhere in the middle. Okay, and if it becomes for example 1, it will give you exactly B minus 1, which will give you the whole distance, which will, you'll end up in the point B. Okay, so it's getting a little messy in the drawings, but yeah, you might get the idea. So it's a simple interpolation method. Unity also has its lerp mathing, but this is actually the math behind your lerp method, which I have coded here. Okay, so I have coded my own lerp method. So the value is coming, I'm taking the start value, and I'm calculating the difference between B minus A. Okay, and then multiplying it to the percentage and returning the value. So that's what's happening here. And since we already have computed our learning curves, which means the percentage values, so in this ease out case, the percentage value is not moving linearly, it's moving gradually. It's ease out, which means in the beginning it's going fast, but in the end it's applying that 1 minus sine curve. Okay, same with that. So it's nothing serious in implementation. It's already I already have those values, and I have passed in here, and the final outcome is there. If you want to see me code this function, you can definitely follow Nikhil Malankar's live, or I have the same on my channel as well, so you can follow there as well. Okay, so if I tap, all the balls are moving in 2 seconds, taking 2-second time to move from A to B, but the motion is different in all. Some motion suits for one sort of animation, some motion suits some other sort of animation. But this practice gives you a lot of idea about interpolations, about motions, about animations and all, and specifically render cycle and all those. So I hope you...
One small clarification, Avi.
Yeah.
What is the real difference between linear and smooth? I mean, in simplest form, what would be the difference between linear? I understand that
yeah.
it's like at same pace.
Okay.
So then what is smooth?
Yeah, let me draw the curve for linear and smooth. So if I draw this curve, so this is linear, 45 degree. You can see this is the time which is moving, and this is the value on this curve. Okay, so 45 degree, which means the value is changing with us the same pace. Okay, and this is the smooth curve which I have implemented for me, which means it will begin smoothly, then it will go faster, and it will end smoothly. Okay, something like that. I'm not very good with drawing, but something like a tilted S, which means it's moving, starting slow and ending slow. It's smooth in the beginning, smooth in the end. Okay, something like this, value and time. Okay, so this is the only difference. It's not... yeah.
Thank you.
It's the motion difference between these two, and in fact all of these are just motion differences. So if I play the animation again, you may notice the difference between these two. Okay. So this is the linear ball, and compared to this linear ball, you have to basically test each motion. So if I compare this linear ball with ease out, you can see ease out is faster in the beginning compared to linear, but slower in the end. You can notice. Now notice this linear ball and ease in ball. So as you can already see, ease in ball is slower in the beginning, but catching up faster in the end. You can see. Now let's compare to Power 2. So Power 2 is slower, but faster in end. Power 3 is a little even more slower, but faster in the end. Got it? And the smooth function is slower in the end, but very fast in the middle, and slower at the beginning as well. So you got the idea. So if you compare, if I suppose turn off all the other balls, if I go here, yeah, I think I can, yeah. So now you can compare between smooth and linear. Can you see? So it's very fast in the
Yeah,
middle,
cool. Yeah.
slower in the beginning, and slower in the end. So this is the
So
comparison.
what did you switch off to switch off the other balls? What
I
setting?
turned off the mesh renderer. I selected the balls and turned off the
Okay.
mesh renderer.
Okay, thank you.
Yeah. So I hope, yeah, this session was interesting. Okay. I hope you guys find it informative. And if you guys have any queries from this session, from rasterizer, from previous session which was related to ray tracing, because this is the last time I think we are having conversation. If you are not joining my XRDI and not having going to this YouTube, searching for example, XRDI, and finding my channel, hitting subscribe. So make sure you do that, because all the lectures, even this one, is already presented there. Okay, so you can definitely do that. And yeah, so yeah, so there are several sort of sessions which happen on XRDI. There is XR news, on which you get updated with what's with that in the technology, and you get updated to that. There is XR podcast, in which I invite mentors from all over the world, and they discuss about their technologies, their journey into these technologies, what is the correct mindset to adopt these technologies, and methods and tricks and ways and all those. So there is XR podcast which happens each week. Every week I do that session with some industry expert all over the world. This week VR Rosie is coming. VR Rosie is a very talented virtual reality artist, and she's a tilt brush artist. Let me just give you a perspective of her art. So if I go to, why my mouse is not working? Yeah, VR Rosie. Okay, so I'm just, okay, Rosie Summers. Okay, if I just play one of her videos, so you can see she wears this sort of headset, and she draw this sort of amazing sculpture inside virtual reality. So it, yeah, saw the end one. So this is her own creation in virtual reality. She created herself in virtual reality. So these sort of creators come to my platform and talk about their art. And there are educational sessions like these one, which happen in 1 month. We are having one series. For example, last month we had a XR masterclass. This month we are having this AICTE series and all those. So you get updated with the technology, with the knowledge and everything on the channel, and we have the community platform and everything. So you can also check our website. On this as well, you get a lot of information about upcoming sessions and what we do and all those. Okay, so these are, yeah, these are some previous events, and this is the poster of my podcast. These are some of my speakers. As you can see, an astronaut is even the part of that. So they are world leaders. All the speakers are amazing, and it's awesome to hear to them. So yeah, you can definitely do that. And on the community page, for example, even I'm doing the live streaming of this. So youtube.com, hold on, youtube.com/XRDI, and even this session is being live streamed. So right now we are on live on my channel, and you can even find previous sessions. Like this is the ray tracer session which we did yesterday, and here are the project link. You can download that. Here is the Canva presentation link which we use there. I modified the presentation so you can find more detail, and I introduce some laws as well, so you should definitely read there. All the links are available there. Okay, so you can definitely check out. These are all the links which you might require. Yeah. So if any other queries is there, I can answer in 2-3 minutes. Awesome. Thank you, ma'am. Thank you. It's really amazing to have the company of you guys, and yeah, I really enjoyed doing these sessions. Thanks everyone, and please do recommend your students about the XRDA. I'm going to share a link with you guys one more time in the chat section. So youtube.com and /XRDITV. Okay, that is the link what they have to care about, and from there they'll find session a more close link like Discord server where they can make their own team of developers, and also they can have the communication networking there. Okay, awesome. So yeah, see you guys on my channel. See you in the next podcast. I hope you attend my next podcast with Rosie Summers, and yeah, going to enjoy a lot. Yeah, thank you guys. This is not very true. I have only 300 something subscribers, so this is not going really well. And though I have taught 10,000 plus students, but the subscriber conversion is really low. Actually, really low. So that is why I have started talking about my channel. Yeah. Thanks, ma'am. You said it very correct. And what hurts is there are communities like Scamhead Junior, and they are investing huge in marketing, and basically fooling the parents about that their students are going, that their kids are going to learn coding, but it's not true. Yeah, yeah. And all the content are available free, but they're investing lakhs of rupees in those platforms. So yeah, that's really yeah, depressing. Okay, yeah, see you guys. Bye, take care.